Hi. Today we are going to talk about message passing and inter-process communications. And we will answer some questions like: what are the main two system calls? What are the modes of communication? What affects message and buffer sizes? Inter-process communication is the mechanism provided by the operating system that allows processes to communicate with each other. This communication could involve a process letting another process know that some event has occurred or transferring of data from one process to another. One of the models of process communication is the message passing model. And for sure, message passing have advantages and disadvantages. The advantages are the message passing model is much easier to implement than the shared memory model. It is easier to build parallel hardware using message passing model as it is quite tolerant of higher communication latencies. And in the other hand, the disadvantages are: the message passing model has slower communication than the shared memory model because the connection setup takes time. Now we will talk about advantages of message passing model. The message passing model is much easier to implement than the shared memory model. It is easier to build parallel hardware using message passing model as it is quite tolerant of higher communication latencies. There is also disadvantage of message passing model. The message passing model has slower communication than the shared memory model because the connection setup takes time. And now we will talk about the main system calls used in message passing process. The first one is send message, destination, or send message. The second one is receive message, host, or receive message. And for the send system call, it takes place through two types: through computer or across a network. And regarding the modes of communication, we will find that we have four modes, and they are: direct communication, indirect communication, synchronous and asynchronous communication, automatic and explicit buffering. And regards the direct communication, we will find that it takes place in under direct communication. Processes must explicitly name the sender or receiver in the communication. The send and receive are defined as: 1. Send P, message, send a message to process P. The communication link in direct communication has the following properties. The link is established automatically. Processes need each other's identity to send messages. A link is associated with exactly two processes. Between two processes, there is only one link. And from the examples is the print server. Indirect communication. In indirect communication, messages are sent and received from mailboxes or ports. The processes can place messages into a mailbox or remove messages from them. The mailbox has a unique identification. Send a message, send a message to mailbox. A receive a message, receive a message from mailbox A. In this scheme, a communication link has the following properties. A link is established between a pair of processes only if both have a same shared mailbox. A link may be associated with more than two processes. There may be different links, with each link corresponding to one mailbox, between pair of communicating process. Synchronous and asynchronous communication. Communication happens using send and receive. There are many options for these two primitives. Message passing may be blocking or non-blocking, also known as synchronous and asynchronous. Blocking send. Sending is blocked until a message is received by receiving process or mailbox. Non-blocking send. Sending process sends the message and resumes operation. Blocking receive. Receiver blocks until a message is available. Non-blocking receive. The receiver retrieves either a valid message or a null. Automatic and explicit buffering. The messages exchanged between communicating processes resides in a temporary queue. The queue can be implemented in three ways. Zero capacity. With zero capacity, the link cannot have messages waiting. Blocking send is the correct option. Bounded capacity. The queue is of finite length n. If queue not full, sender can continue to send messages. If full, blocking send. Unbounded capacity. Infinite queue length. Any number of messages wait and sender never blocks. 0. Message and buffer size. Message size can be a fixed size or a variable size. If it is a fixed size, it is easy for an OS designer but complicated for a programmer, and if it is a variable size, then it is easy for a programmer but complicated for the OS designer. A standard message can have two parts, header and body. The header part is used for storing message type, destination ID, source ID, message length, and control information. The control information contains information like what to do if runs out of buffer space, sequence number, priority. Generally, message is sent using FIFO style.